Okay, this is in your instruction book, 8th graders. It is page 178. All right, you gotta read the problem and explain and describe a transformation that maps the polygon into the congruent one. So it says you can describe in words how it happened. This transformed into this. You're explaining how the different numbers turn into other. It's basically saying this point turned into this point turned into this point, and this point remained the same. Okay? You can picture it and say that they transformed, and which part transformed. So Z became Y, W became X, 0 transformed itself. This is your example. That's all you have to do for 178 is read the example. For 179 on the back, what kind of transformation was used? So when you're talking about the different transformations, you want to make sure, like, is this a reflection? Is this a translation? Is this rotation? So looking at it, and it looks like an exact reflection. So explain. This is a reflection because the numbers and spaces are the exact amount away from the y-axis. Okay, they're the exact amount away from the y-axis. So what happened to our example, if we go back, they're exact, this is a reflection because it's going the exact number away and it matches. Okay, and they have a point of origin where they're matching. Write and then compare the coordinate planes for these vertices. So we're talking about what Z looks like. And then we're talking about what the other ones look like. So when we're just talking about Z, they said Z transformed into Y. But when you have to find Z on this page, it's right here. And it's at 1, 2, 3, 4, negative 4, 0. So negative 4, 0. Y is at 4, 0. So they're trying to get you to see this is going from negative to positive. The X values are the same distance. First is negative. Second is positive. Okay, now we have to look at W and X. Let me flip over. Looking at W, this is at 1, 2, negative 4, 2. And this is at positive 4, 2. Negative 4, 2, 4, 2. Okay. How does the answer to problem 8 fit within the location to the original figure and its reflected images? So it's a very complicated way of saying they're on the same grid. They are on the same, I guess I'll say horizontal line because we're talking about X. Horizontal line, X, but opposite ends. Negative and positive. All right. How does a reflection of a figure change the coordinates of the vertices? So we're just explaining what we set up here, down here. So the Y does not change, but the X goes from negative to positive, or becomes the opposite because it can also go from positive to negative. All right. Use what you learned to transform and solve these problems. So it says we're going to move it. ZWO is moved 2 units to the right and 1 unit up. Okay. 2 units to the right and 1 unit up. So 2 units to the right and 1 unit up. 2 to the right and 1 up. 2 to the right and 1 up. The new one. Okay. So they want the original units, which we already know. We have -4, 0 up here. ZW, -4, 2, 0, 0. Now what are the new ones? Let's look at what we drew. There he is. So we've got 1, 2, -2, 2, and -2, 4. -2, 2, -2, 4, and 0 even changed. 0 moved to be, these are here, oh, 0 moved right here. 1, 2, up 1, 2, 1. You can most clearly see the pattern in the 0 because it went 2 over 2, 2 right, 1 up, which was what they told us to move, right? But this also moved 2 and 1, 2 and 1. So this would be 1. Well, it looks like 2 and 2. 2 units to the right and 1 unit up. So it should be 3. 2 units to the right and 1 unit up. All right. Compare the corresponding virtues. All right. So that matches it. Compare, what do you notice about the different, the x values, y's? The x values went up or right. They went right on the scale by 2. The y values went up on the scale by 1. And that's what it asks you to do. It said go 2 right, 1 up. So all of these, it's reflected in their x and y. They went to the right 2, up 1. Okay, and that is page 178 and 179.